Recently I've been obsessed with making RC cars. I started out with a small proof of concept design a few months back, and it was neat to watch how the design evolved over time. This car only had the basics. It didn't have a universal suspension, and the tires were literally taken off of a Lego model. Even still, it managed to reach 20 miles an hour. Nowadays, it sits right here, and it's being slowly broken down to have its parts reused for other projects. Next up was this unit right here. Measuring 18 by 18 inches, this thing never properly got running. This was another proof of concept kind of a project. I was testing out multiple systems here at once. I had made a turbine, a transmission, a differential, independent wishbone suspension, and universal joints. Needless to say, this thing was a rough design, but everything worked to some degree. So basically, the suspension and axle geometries were the quick and sad downfall of the turbine car. In reality, there were countless other issues that never got to appear since the system as a whole failed so early on. I was planning to make my next video on wrapping up this project, but you guessed it, this thing kinda sucks, and I wanted to start all the way from scratch again. Believe it or not, I did my research going into this one. My goal is to wind up with a design that has really good handling, modular and functional aero, and tailored suspension. Mainly this time I wanted to focus on the suspension geometries because that's a pretty interesting level of complexity that my printer should have an easy time manufacturing. For this suspension setup, I incorporated a kingpin angle. This one naturally makes the wheels want to align to go straight. I also added some caster angle, which makes the outside wheel have more negative camber when turning. And the opposite is true for the inside wheel when turning, and that's going to be important specifically for this design, and I'll cover that later on. Lastly, here is the wheel center recession. This one makes the wheel bump up and backwards when the suspension flexes versus just straight up. I started by CADing up the front suspension using all of the geometry stuff I just researched. After simulating how everything would work in CAD, I printed some prototype parts to see how it would all interact. The suspension took a few tries to get right, same with the tolerances with the ball joints and the suspension arms. You can see the angles that I talked about earlier displayed on this prototype, which will hopefully aid the car's handling. This bit here is the wheel hub, and it took several tries to get right in CAD as it had a lot of limitations and requirements. I needed to use these massive 21mm bearings for the axle. I also needed a way to secure the hub to the ball joints on the suspension arms. Lastly, this part needed to fit naturally with the strange geometry setup. The hub has this large cylindrical body to house the bearings in the shaft. On the top and bottom, it has differently positioned connection points, each of which has a hex nut slotted inside. I configured this so that a bolt can go through the ball joint inside the hub and tighten against the nut inside. The suspension arms are held to the frame with 4M bolts and nuts, same as the suspension. After some iterative designing, I moved on to work on the body of the car in CAD. In this time lapse, I drew up a rough idea of what I thought the body of this should look like. It turned out to slightly resemble a scaled down electric skateboard. As far as other little things that I've done so far, I've designed and tested the universal joint axles, which will also be 3D printed. I have also figured out what wheels, motor, and electronics I'll be using. This is about as far as I've gotten so far. I've been pretty busy recently, but now I've got more time to work on projects like this, so hopefully the next video on this will be out soon, and I'll have gotten a lot done. I appreciate it if you've made it this far, and thanks so much for watching.